Alright, let's look at the homework 8.1, problem number 9. Alright, so we want to find the arc length function for this given function. Right? So first, let's find the derivative. dy over dx, right, is equal to, right, derivative of arc sine is 1 over square root of 1 minus x squared. Right? And since I don't like square root, I'm going to rewrite this second term as quantity 1 minus x squared to the 1/2 power. Right? So derivative is going to be, I put 1/2 in front, keep the inside function as it is, so quantity 1 minus x squared. Subtract 1 from the power, so it's negative 1/2. Then multiply by derivative of the inside, so it's going to be negative 2x. Alright, so we can cancel 2 on top and 2 on the bottom. Alright, so then what you get is going to be, so we need to simplify this. So I'm going to go here. Alright, so you have, let's see, 1 over, actually, we have a 1 over square root of 1 minus x squared, right? And we do have the same denominator here. If you look at this part here, this is just 1 over square root of 1 minus x squared. So we need to have the numerator. So numerator is right here, negative x, right? So you have a minus x here. Right? Then, so we have the derivative. So let's simplify the integrand, right, for the arc length function. Right? So it's going to be 1 plus, right, dy over dx squared. So we have to square that guy. So we're going to have, right, so we have 1 minus x squared. Right? Then if you square 1 minus x, you're going to get 1 minus 2x plus x squared. Right? And take the common denominator. So we have a square root. Right? Then you're going to have, let's see, we have 1 minus x squared, because we have 1. So 1 minus x squared. Right? Then you have a plus 1 minus 2x plus x squared. Right? Then we can cancel. There's a negative x squared there and a positive x squared. And put them all together. Looks like we have 2 minus 2x. So I'm going to pull out the 2. Then 1 minus x. And the denominator can be factored out as 1 minus x times quantity 1 plus x. Right? Then there's a square root there. Alright, so we can actually cancel, let's see, 1 minus x here and 1 minus x there. Alright? So this is going to be, right, so you have a square root of 2, so square root of 2, I'm going to actually put it out here, right, that's square root of 2, and over 1 plus x with a square root. So I'm going to write it as 1 plus x, then since it's on the bottom, negative, because of the square root, it's a 1/2 power. Alright, so that's the integrand. So if you want to find the arc length function s of x, right, this is going to be equal to integral from 0. So 0 comes from the point, starting point. So x coordinate of the starting point is 0. Then it goes to x, right? Then I just have to write it in terms of t. So it's a square root of 2, right? And then you have 1 plus t raise it to the negative 1/2 power with respect to t. Right? Then take the antiderivative. So first I'm gonna put the square root of 2 outside, and then antiderivative is going to be add 1 to the power, so you have 1 plus t to the positive 1/2 power. Divide by 1/2 is multiplied by 2. Right? Then you're going from 0 to x. Right? So I'm gonna pull 2 outside here. So we're gonna have, so I'm gonna go down here. You have 2 square root of 2. Right? Then we plug in x, so you have a square root of 1 plus x minus, right, plug in 0, so it's going to be 1 to the 1/2, so it's going to be 1. Right? So maybe I'll put the parentheses instead. Alright, so this is the arc length function. Right? So let's type this guy in. Right? So arc length function we got is 2 square root of 2 and times square root of 1 plus x and plus 1. Actually minus 1, sorry. Minus 1. Right, let's check the answer. Submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.